All right, ladies and gentlemen, we're going to have two quick exponential topics today. And the first one is graphs. We've talked about how the general form of an exponential function is a times b to the x. A is kind of like the starting point. That's going to be the intercept because think about it, if x is 0, then b to the 0 is always 1. Anything to the 0 is 1, so that's gone. And we just get a. So a times b to the x is going to start at a, and b is going to tell us how much it goes up by, how much it multiplies by every time x goes up 1. The general shape of these graphs is like this. If b is greater than 1, then your graph's going to look like this. This is what we call exponential growth. Okay, and then there's also, on the other hand, exponential decay. And I'll use an example for exponential decay. 10 times 1/2 to the x. Okay, 10 times 1/2 to the x. It's still going to go through 0, 10. But this one's going to be cutting in half each time. When x is 1, our y value is down to 5. When x is 2, we're down to half of that at 2 1/2. Then we're down to 1 1/4. And this one goes the opposite way. Okay, so think about some features of these graphs. Where you have asymptotes, your domains and ranges. Let's look at this blue one, for instance. The domain is all real numbers. There's no x that you cannot plug in. And even though this line looks like it's, it looks like it might approach an asymptote, something like that, it's not going to. It's just really, really steep. So you'll have to go a long way up before you make any real progress to the left, but that's what exponentials are. They are really steep, steeper than power functions, x squareds or x cubes in the long run. But it will eventually, this red one will eventually go all the way to the right, the blue one will go all the way to the left. So the domain is all real numbers for both of these. If you don't know already, this R with 2 stumps, that means all real numbers. The range is anything above the y-axis. So we could say y is greater than 0. Exponentials, unless you transform the equations with a negative sign, always exist above the axis. You can't raise a number to a power. You can't raise a positive number to any power and end up with a negative answer. Even if your b is a fraction, that's not going to make it go negative. That's just going to flip it around and make it decay. We could add to these and shift them up or shift them down, but the general form is going to go through the a value, and b will determine the growth or decay. I want to spend some more time on today's lesson about compound interest. Compound interest is probably the most relevant application of exponentials, maybe even of all the math you do. Interest is both a great thing and a horrible thing when you become a grown-up one day, or when I become one day. You get interest by putting your money into the bank or putting it into the stock market or some sort of retirement fund. You pay interest when you want to buy something and you don't have enough money for it. When you want to buy a house, if you don't have enough money to buy a house, which most of us don't, then you go to the bank and say, bank, I want to buy a house. It costs $200,000. And they say, okay, we'll give you $200,000, but you're going to pay us back way more than $200,000 over the next 30 years, for example. So on the good side, you need to invest and make interest, and on the other side, you're going to have to pay interest anytime you want to borrow money that you don't have. We'll talk all about it in class. I'll give you some wise words. But let's just talk simple for a bit. Let's talk about compound interest. Simple interest would be something like, hey, give me $1,000, I'll give you back 1,100 in a year. That would be simple interest. You give you either give somebody money or they give you money, and then that person pays back a little bit more. Um, Compound interest, this is the magic that lets you retire as a millionaire if you choose. The formula for compound interest is this. You need to make sure you have this formula down, and you know what all these letters stand for. A is how much you end up with, the current amount of money in the bank. P is principal, which is how much money you put in the bank. R is the interest rate. And when we put, if the bank's going to pay you 5%, you need to make it a decimal, so 0.05. N is the number of times a year that they're going to compound your interest. Explain what that means in a second. And T is time, or how many years. So here's an example. You take your money to the bank. And you say, bank, here's $1,000. And they say, okay, we're going to give you 6% interest. Don't know if that's doable these days, but maybe. $1,000, they'll give you 6% interest at the end of the year. So they're just going to compound it. They're going to give you your interest. That's money you make by doing nothing but giving your money to them at the end of each year. So you go in 1,000. A year later, they say, okay, here's your 6% interest. Let's use the formula. Even though when it's annually, the formula kind of gets real simple. How much we have is how much we started with, 1,000, plus 1 times 1 plus 0.06, remember it's a decimal. The reason that when you do annual, its formula gets real simple is that number of times compounded is 1. So really we just get 1,000 times 1.06, which is $1,060. So you made $60 by just letting them have your 1,000 for the year. Fair enough, easy money. Now that's not too impressive. That's not going to make you a millionaire. All right, we have to talk more about that. That's when you invest over the entire course of your working life, and then you can be a millionaire. But simple problem, $60. It's not bad for doing nothing. What if, however, you decide, bank, I'm going to go to another bank because they're going to give me my interest every month. The benefit of compound interest is as soon as you get interest, that interest starts earning its own interest. Now, it's not going to be a big difference, but let's just see how much of a difference it is. If they, at the end of the month, give you interest, and that interest starts earning its own, and then at the end of the second month, they do the same. Here's the thing, though. They're not going to give you the full 6% every month. That would be like them giving you $60 the first month and then a little bit more than that the second month. They're only going to give you a 1/12 of the 6%. That's why we take our 6% and divide it by 12. But we get to use the power of exponents, and we get to raise this to the 12th power now. So I'm going to get the calculator out for this one. If we have $1,000 times 1 plus 0.06 divided by 12 to the 12th power, and wrong button, try that again, 1,000, 1 plus 0.06 divided by 12, close to the 12th. Here we go, 1,061.68. So, you get an extra $1.68 over the course of that year if they compounded it monthly. So whether they do it annually or monthly, it's not a big deal in the short term, but what if they did it, every week or every day. I'll leave some of those examples for us to explore later. One thing I want you to see for sure, this is for a year. You haven't allowed your money to grow very long. Let's just say it's 10 years. So we could take that same expression, and I just did it to the 12th power because according to my formula, which is here, t is how many years I'm willing to leave my money in the bank. So let's make t 10, which makes my exponent 120. I'm still going to go with the monthly, but this is going to be for 120 months. So let's see how it looks then. Now we're talking. Now your 1,000 is turned into $1,819. All right, so it's sort of started to make that characteristic tipping point that we see in exponential graphs. When those get steep, that's what you want to happen to your money. So we've made 800, we've almost doubled our money for doing absolutely nothing. What about another 10 years? Okay, so that would be 240 months, true? That would be 12 times 20 for my n times t. So let's make this 240. Remember, we just gave them $1,000, 6% compounded monthly. Now we're really talking. Over the next 10 years, we went from 1,800 to 3,300. That's $1,000 we just gave them. And now 20 years later, we have 3,300 for doing nothing but just sitting there and letting them have our money. Now, again, you're not going to be a millionaire that way, but if you give them $1,000 every so often, and you keep giving them another 1,000, now you're talking. You got to invest as much as you can, as soon as you can. I'm going to graph this. I'm going to pause and graph this so you can see the picture. Okay, I'm back. This is the equation. 1,000 times 1 plus 0.06 over 12 to the 12, and I made an x instead of t. So my variable, my x variable, is the number of years, and here's a picture of it. Remember, you started with 1,000, and it started to grow, and it got steeper and steeper and steeper. The interest started earning its own interest, and that's how it gets steep. Okay, so that's what you want to happen to your money. That's why you need to invest it soon. All right. On the other side, we can talk about mortgages too. It's when the bank just takes your money like this, but it's another story. So anyway, that's going to be it for today. Remember this formula. We'll do some practice in class, talk about how to become a millionaire, and Young out.